All right, so this section we are going to explore quadratic graphs. Remember in the previous section when we were doing factoring and things like that, we talked about quadratic equations in the form of ax squared plus bx plus c. So ax squared plus bx plus c. We did a lot of factoring of those, and now these are quadratics, and we're going to talk about the graphs that they make. When we do put these in, and we're going to use graphing calculators, we're going to use a Desmos function where we can explore the shapes of these graphs. But these all make what they're called U-shaped graphs, right? Here, we're going to talk about that right here. So a quadratic function, just not get ahead of ourselves, is a function in which the highest degree of any term is 2, meaning something x squared. So we've talked about these before. The simplest quadratic function, or the parent function as it's known, is y equals x squared, and that's what's listed right here. The graph of a quadratic function is a U-curved graph, so they're all going to be in this type of shape, either a right side up U or an upside down U. The name of this U-shaped graph is called a parabola. P-A-R-A-B-O-L-A. So as you hear me referring to that, it's just the shape of that actual graph. All right. So one of the other terminologies in this first page is really just covering a lot of vocabulary. One of the properties of parabola is that you can fold them in half. So one side is going to be basically a mirror image of the other side. You can see that this dot and this dot are the same apart. This dot and this dot are the same apart. And when we can do that, when we can mirror something, there's a property called symmetry. All right, so symmetry means it's the same on one side as it is the other. Now, when we look at this graph, there is a line that is cutting that in the middle. We call that the axis of symmetry. The axis of symmetry. All right, so in this particular case, we can see here, and this is just the same graph, the axis of symmetry of this is our y-axis. All right, it's not always going to be the y-axis, but in this case, it is right here. So if we folded right on this, if we had this printed out, we folded across this half, would line up right onto that half. Okay, so just a few terms. U-shaped graph, parabola, axis of symmetry, this line right here. And then, of course, in the parent function of y equals x squared, the y-axis is the axis of symmetry. All right, the next page. There is another part that we need to talk about. It's called the high and the low point of a parabola. All right, and that is known as the vertex. Vertex. All right, so the vertex is basically where the graph would either be at its lowest point or its highest point. All right, so the vertex is an important part for when we get into graphing. If we are comparing a graph, hey, where's the high point, where's the low point? So this is a big concept that we will be using a lot to understand graphs. Now, when you look at this notes right here, it says when a is greater than 0, meaning this point right here, when this part, right, is positive, when our a is positive, it opens upwards, so it's going like this. All right. If a is less than 0, meaning it's a negative, it's going to open downward this way. So key points with this is, as long as we can see that it's positive or negative here, and we start graphing, we can see that we should know that it's going to open down or up. So algebraically, when we start graphing these things, if you see that it's a negative 2x squared, blah, 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 something like that, and your graph ends up going like this, those are not going to match up. So maybe you made a mistake algebraically somewhere in your math. All right, so a couple more pieces of terminology. When a parabola opens upward like this, you can see that we have our vertex down here, and that is the lowest point of that parabola. That is known as a minimum, the minimum of the graph. I'm just going to put min to abbreviate. So minimum, And when it opens downward, and you can see that the vertex is right over here in that spot, and we can see that that would be considered the maximum of a graph because it's the highest point. All right, so graphs are either going to have a minimum, or parabolas are either going to have a minimum or a maximum, and that is the same as our vertex. All right. So when we are looking at a graph, it's, we want to be able to identify where the vertex is. When we actually graph these, we're going to have to start with the vertex, and we're going to figure out how to do that later. But if I'm looking at this, it says identify the vertex of each graph, tell whether it is a minimum or a maximum. All right, so I'm going to put a dot where our vertex is. So this is our high point. And these graphs didn't copy well because we can't see our lines, but this is the high point of the graph. So the high point, again, from your notes that we just talked about, is going to be a maximum. So that's a max, is our vertex. And the ordered pair where the vertex is. Now we're going to write this as an ordered pair in parentheses. Remember, ordered pair is x first, y second. So if I look at my x-axis, 4 is lined up with this. So 4 is my x. And I look where my y is. This would be -2, so that would be +3. So my vertex for this graph is 4, 3. This graph, we can see that it is opening upward, so we have a minimum. And it's not going to be crucial that you know what a maximum and a minimum is, just that you're aware that that terminology goes with these. But identifying the vertex is a little bit more important. We're going to label it there. So my vertex for this one would be, listing my x first, my x is here. So you can see it's lined up with -3, so -3 for my x. And my y would be also -3. So -2 is here. So we go down one more unit, and that's -3. All right, so the next page that we're going to cover in this video is just being familiar and being able to recognize points on a graph. So here's a couple practice problems. What I want you guys to do is identify the vertex and one known point either or to both the left and right of the vertex. All right, so I'm going to do this first one, and then I'm going to have you pause this and actually fill this one out on your own. So I'm going to label my vertex. I'm going to put a dot where my vertex is. Remember, that's that minimum. It's the low point. Remember, your x is first. This is your x. This is your y. See x here, y there. So our vertex for this graph would be -2 for my x and -3 for my y. All right. Now one known point to the right. So I'm going to follow this graph, and I'm going to look to where this graph crosses exactly at 2 known numbers. There's a couple here. We can see one right here. And that's not quite, because that would be right there, but I believe this would be another one right here. And we talk about the axis of symmetry. The axis of symmetry for this particular graph would be -2. The other one was our y-axis. But you can see here, this would be our axis of symmetry. And if we folded this over, we get equal distance away from that. So 1, 2 right here is equal distance away. 1, 2, here's another known point. I mean, they're mirrored all the way across. So that's going to help you when you're identifying other points. And when we actually graph these algebraically, there's a quick way to do it. All right, so here's another point right here. So for this case, for the sake of this, I just want you to identify one point to the right, one point to the left. So if I look at this point to the right, my x value is 0, and my y value would be -1. All right, so if I look at the axis of symmetry, the mirrored image of this, the point on the left here would be -4 for my x and -1 for my y. So the -1 is going to be the same. We're just going 2 more units from that axis of symmetry. All right, see if you can do this one. I'm going to go ahead and work on this problem now. So our vertex would be here. This would be 3 for our x, 1 for our y. So 3, 1. And then we have known points on either side. So I'm going to write this up. I think here's one right here. I'm going to go all the way across, and I have that other known point. So point to the right, if I look at this, I have 6, 7. And then I have 0 at my x, 7. So just get familiar with knowing points to the right and to the left of these graphs. Okay, the final part that we're going to cover is comparing widths to a graph. So in the form y equals ax squared, the bigger the a, regardless of whether it's negative or positive, the skinnier or narrower the graph. The smaller the value for a, meaning like if it's a point or a decimal point or a fraction, the wider. So we can check this, and I'm going to bring up Desmos, a graphing calculator. All right, so this calculator should look familiar because it's one we've used before. But if we go to this, there's actually a graphing portion that we can use. Oops. And instead of scientific, I'm just going to go to the website. Yeah, math tools, we're actually going to go to the graphing calculator. So this is going to show you how the different widths of this would play out. And this is one way that you could do this. I'm actually going to type in these graphs. Y equals x squared. So y equals x. And I'm going to put that square in there. Now I'm going to go to another line. I'm going to put y equals half x squared. So y equals, and I'll do 1 over 2 x squared. All right, so you can see right now, because it's smaller than 1, it's wider. And then this third example, we have y equals negative 2x squared. Now negative 2, remember that's going to be should be opening down because of the negative. So y equals negative 2x squared. All right, so I'm going to make this bigger in a second here. But if we are talking about an example question, so listing these from widest to narrowest, for example, remember the bigger the a, so the higher number, so like negative 2, even though it's negative, is bigger than a half and it's bigger than 1, right? So negative 2 is going to be the narrowest of the three, followed by 1, and then the widest would be a half x. So if I go back to this Desmos calculator, and you can kind of see this here, if I scroll out, you can see that, I mean, it's kind of hard to see here with between the red and the green, but this is a little bit narrower. One way we could tell, because the width is going to be the same whether it's negative or positive, if we said y equals 2x squared. All right, there you can now see the difference between all three graphs. So the narrowest is going to be the negative 2x squared in this example, or the 2x squared here. The next, we can see the red one here, would be the x squared, and the half would be our widest. So as we're doing these types of questions, if you need to use that Desmos calculator to type that in, you can, and then you can actually visibly see them. Or if you get good at this and you remember that, hey, the bigger the number, the narrower it is. So if we're going to list these from widest to narrowest, it would be the y equals half x squared first. The next one would be y equals 1x squared. That's the same as that. Remember, there's a 1 there always. And then the narrowest graph would be the y equals negative 2x squared. So if you get questions on that, listing them in order from widest to narrowest, you can always use that graphing calculator, and we'll practice that in class. Or you can just know that, hey, the smallest is going to be the widest, and the bigger the number of a is going to be the narrowest.